Hello friends. In our last session, we have seen two important set operations, namely the union of the set as well as intersection of the set. Today, we are going to analyze the remaining three more set operations, namely the difference between set, the complement of a set, and finally the partition of a set. Welcome to the session. Now we have the third operation, namely the difference between set. Now let us suppose that we have two sets. Let us say that we have set A as well as set B. Now the difference between the two sets, let us call it as A minus B, the difference of B from the set A. The difference between set B from A, or what we call A minus B, consists of all those elements that belongs to the set A but does not belong to the set B. What was that? A minus B consists of all those elements that belongs to the set A, or is a member in the set A, is an element in the set A, at the same time does not belong to the set B. In our familiar description form, A minus B can be written as like this. It is the set of all X such that X is an element in set A and X is not an element in set B. Clear? A minus B consists of all those elements that belongs to the set A, is a member of the set A but does not belongs to the set B. We try to draw it using a Venn diagram. We have something like this. Let us say we have a universal set like here. We have a universal set, and let us have a set A like here. We have a set A here and a set B here. Now, what is A minus B? A minus B consists of all those elements that belongs to the set A but does not belong to set B. So this portion, this shaded portion of set A, this shaded portion of set A that belongs to this set but does not belongs to set B, because this portion belongs to set B as well. That means only this area, only this shaded area is what? This is nothing but the A minus B. So A minus B consists of all those elements that belongs to the set A, is a member in the set A, is an element in the set A but does not belong to set B. Okay, now let us examine this with a hypothetical example. Let us say that we have an example, something. Let me just remove this. We have two sets. Let's say that we have two sets, say set A equals say 2, 4, 6, 8. Set, say we have a set B that equals say 6, 9, 11, 12, something like this. So we have two sets, set A 2, 4, 6, 8 with 4 elements, set B 6, 9, 11, 12 with 4 elements. Now what is A minus B? A minus B consists of all those elements that belongs to set A but does not belongs to set B. Now check for the elements. The element 2, the member of which is 2, which is there in the set A, does not belongs to set B. So we have answer 2 here. 4, no, it's not there. 6, it's common. No, we cannot have. 8 is again. So these three, so A minus B in our example, in our typical example is 2, 4, 8. Because these three elements do belongs to the set A but does not belongs to the set B. So A minus B, or the difference between two sets, can be explained in this way. Given the two sets A and B, A minus B consists of all those elements that belongs to the set A but does not belong to set B. In our description example, it's a set of all X such that X is an element in A and X is not an element in set B. So that's the difference between C set, which is our third operation or third set operation. Now, let us very quickly explain the fourth operation. Now we have the fourth set operation, namely what is known as the complement of a set. So what is the meaning of complement of set? Now let us suppose that we have a universal set, and let me call it as U. We have a universal set and a subset of universal set. Let us say that we have set A. And A is obviously a subset of the universal set, because every set is a subset of universal set. Because we have seen that universal set is nothing but an all-inclusive set. So every set will be a subset of the universal set. Now, we have a universal set, and a subset of it which we call it as A. And in our Venn diagram, if you try to draw it like this, it will be here. We have a universal set here and a subset of universal set. Let us say that we have a set A here. Now, complement of A usually denoted as either this way A dash, or you can call it as A raised to small letter c. This is how the complement of A is written. So complement of A consists of all those elements that belongs to the universal set but does not belong to set A. So the complement of set A means all those elements that belongs to the universal set but does not belong to set A. So A complement can be written as, let me call it as A dash or A raised to C, A with the power of C, or it is in fact consist of all those elements. X is an element in the universal set and X is not an element in A. That is, A complement is defined as consist of all those elements that belongs to the universal set but does not belong to set A. Now, let us explore this case with our example, our Venn diagram. So, we have a Venn diagram here. So, what is the A complement? A complement consists of all those elements that belongs to the universal set but does not belongs to A. Now, where will be the point? All these areas of universal set, which is a member in the universal set but does not belong to set A. So this area, this portion of the universal set that in fact belongs to the universal set but does not belongs to, so this area is nothing but our A complement. It can be written as either A dash or A raised to C. So A complement consists of all those elements that belongs to the universal set but does not belong to the set A. Now let us explain this case with an example. Now we have, let us say that we have an example, and hypothetically, so let us write it as we have a universal set, right? We have a universal set like U equals say 1, 2, 3, 4, 5, 6. And we have a set A, which is obviously a subset of the universal set. We have a set A equals say 3, 4, 5. With these two sets, you can see that the set A is obviously a subset of the universal set. Now, what is the complement of A? As we said, complement of A consists of all those elements that belongs to the universal set but does not belongs to set A. So what will be the answer? A complement equals all those elements that belongs to the universal set. Now check for the element, the first one. 1 is there in the universal set but does not belongs to set A. So 1 is there, 2 will be there, 3, 4, 5 will not be there, 6. So this will be our solution. So A complement consists of all those elements that belongs to the universal set but does not belongs to set A. So that's the complement of a set. Now we will end up the operation of set with our final kind of set operation, and which is not frequently used, but still is an important for our analytical purpose. And now we have the fifth and final one, which is the partition of a set. Partition of set means you are trying to divide set into number of disjoint sets. So you have a set, for example, say we have a universal set is say like U. It can be divided, it can be partitioned into number of subsets who are disjoint in nature. What was disjoint set? Non-overlapping, mutually exclusive, where the intersection set will be an empty set. So that the universal set U is partitioned into a number of sets. For example, say A1, A2, A3, A4 and so on, whose union in fact A1, A2 union, A3 union up to say union AN. So when you calculate all the union of the set, you will get the original set U. And the important point is that the intersection between the sets, intersection between these subset will be an empty set, because it is assumed that these sets are mutually exclusive, non-overlapping, disjoint set. And let us mathematically put it as A1 intersection A1 intersection A2 will be an empty set. There will not be any part that is common to these sets. So you have a situation in which the union of these sets in fact forms the original set, and the intersection between these subset will be empty sets, because these sets are assumed to be non-overlapping, mutually exclusive set. Now let us put in case of an example. Let us say that we have a set like this. Let us say we have a set like this. Hypothetically, you have a set like this, say A, B, C, D. Now how to make a partition? Let us say that you have a partition like this, like A1 equals A, B. You have a set A2 which equals C, D. See here, this is the partition. You have in fact made a partition of the original set, and if you calculate the union of these two sets, A1 union A2, you will get the original set. That means A1 union A2 will be U, and again you can see that A1 intersection A2 will be an empty set. Clear? A1 intersection A2, because there is no common, there are no common elements, obviously they are mutually exclusive sets, they are non-overlapping sets. So that's the meaning of how to make a partition of a set. So when you make a partition of set, 2 points should be remembered. One, the union of the partitioned set will form the original set, and finally there will not be any element that is common, that is there should be a non-overlapping disjoint mutually exclusive set, which is the fifth and final of the set operation. So we have seen 5 different set operation: the union of the two sets, the intersection of the two sets. These 2 topics were discussed during our last video, and today we explore the difference between set, the complement of a set, the partition of a set. Hope that these sessions are useful to you. So until we meet next time, stay safe, happy learning.